Looking back, one of the earlier things we learned this semester, which is the general linear model, it states that all the data at our disposal is split into two separate groups. One group consists of the data that our model can predict, and another group is the error group, which is the data that our model cannot explain. Knowing this, we can apply this to the ANOVA model, which is also an acronym, which stands for Analysis of Variance. You can view it as being very similar to the regression model, except that the main difference is that a categorical variable is being used to predict a continuous dependent variable. Now, for some examples, essentially think of the three-way ANOVA as just a two-way ANOVA with one more independent variable being compared. Take, for example, you're trying to find how a combination of three independent factors, including age, sex, and body composition, affect how quickly the body absorbs alcohol. Now, each of these independent variables can be split off into different levels. Sex is male, female, or transgender. Body composition can be underweight, normal, obese. Finally, age can also be split up into different age ranges, including 20 to 35, 35 to 50, 50 to 65, so on. Also, keep in mind, you'd want a various treatment groups that consider every possible combination of these levels. Now, for some assumptions you have to make that are very important before you can even use this model, you would have to make sure that your dependent variable must be continuous. Secondly, the three independent variables should each consist of at least two or more categorical independent groups. Third, independence of observations, which entails that the observation in or between the groups must be independent of one another. Fourth, no significant outliers should be present. Fifth, a dependent variable should somewhat follow the normal distribution for all the combinations of the three treatment groups. And sixth, homogeneity of variance for each of the combinations for the three treatment groups. That is to say that they are all roughly the same. Now, why exactly do we use the three-way ANOVA? The three-way ANOVA is a test simply to find out if the data obtained from an experiment, survey, or so on are all statistically significant. Essentially, they help us determine if it is appropriate to reject or fail to reject a null hypothesis. For example, in engineering, specifically industrial engineering, say you're attempting to optimize your supply chain or a specific part of it. You could take three of the independent variables from the mechanism of the actual product creation, and things along the lines of optimal temperature, range, best days or time to do certain things, the list goes on, and then you can essentially, with the model and the data, optimize this to best fit the supply chain.